steel, fire, and pure mechanical force. From ship engines to tunnel segments, witness the incredible process behind the machines that move our world. You're watching LALSHOW. Let's begin. Gearless propulsion. It's a good time to learn how power systems designed to propel really big ships like icebreakers, tankers, ferries, and gas carriers are created. In order to join prefabricated components together, specialists make extensive use of heat shrinking. Due to cooling, the material shrinks. The part slightly decreases in size, but it is enough to give it the desired position. And later, when the temperature rises to room temperature, the part acquires its original size and is securely fixed. This is how, for example, the stator is installed. In general, the assembly process is highly complex, time-consuming, and only performed by highly qualified personnel. Sleepers. In recent years, railroads have been increasingly using sleepers made of reinforced concrete, which, unlike wooden sleepers, require extremely rare replacement. Concrete mixture is used as a raw material, but craftsmen are not in a hurry to pour it into molds. First, a specially trained worker checks each mold and, if necessary, manually removes the remnants of the old mixture. Then all the inner surfaces of each mold are coated with grease. This is to ensure that the finished cured product does not stick. Finally, automated machines place reinforcing bars inside the mold, 4 pieces per sleeper. In the next step, automatics tension the bars, creating tension in the metal, which is later transferred to the concrete, increasing its strength. And only after that, the molds are first poured and then the material is compacted using vibratory impact pads. After curing in an oven at 158 degrees Fahrenheit, the sleepers are ready for stress relieving and finishing. Quarry dump truck. Creation of special equipment is such a complex, long, and full of stages process that in the video we can show only a small part of it. A few years ago, Liebherr Company opened the secret of its production. It showed exactly how the machine, which is one of the largest on the planet, heavy dump truck T282C, is created. Different parts of this dump truck were created in different parts of the world. Drive and gearbox, for example, were assembled in Germany, discs were cast in Canada, and the chassis in the USA. Then all these parts were in Australia, where the body was made and the final assembly was carried out. The latter, by the way, is performed in the open air and in the place where the car will be subsequently used. This saves significantly on transportation, because the weight of the T282C reaches 250 tons. Transportation of parts on the site, as well as their lifting, is performed with the help of a truck crane, forklifts, and other equipment. Ship engine. Now we will show how the world's most powerful internal combustion engine 12X92DF was created, for the manufacture of which the Swiss company Wing D was responsible. Its weight is 2,100 tons. At the same time, it demonstrates a power of up to 64,000 kilowatts at 80 revolutions per minute. This is the amount of power required to drive the OS containers with a capacity of 23,000 containers. A separate construction hangar was allocated for the working process of creating this giant. Multi-ton parts were moved around the facility by powerful horizontal elevators. The parts required for assembly were shipped from all over the world from more than 15 countries. In total, approximately 25,000 people and hours were spent on the entire job. Bevel gears. For the realization of gears in various equipment, machinery, and machines, such bevel gears are actively used. As a billet, an alloy of cast iron and various non-ferrous metals is selected. The exact composition determines the strength and performance characteristics of the finished product, so it is selected for each specific project. First of all, the billet with a square cross-section is heated in a flame or electric furnace. From the high temperature, the material changes structure, becomes soft. able to take any shape. Therefore, further follows the rolling process, when the square current turns into round. The long billet is divided into billets with a size approximately corresponding to the size of the future wheels. They in turn are cooled, and in several stages are processed on a lathe and milling machine. Finally, a gear grinding machine comes into operation. When the product is in its final shape, it is reheated and then cooled sharply to increase its hardness. Excavator. For a look at the next manufacturing process, let's head to Komatsu's facility in Bentley, UK. This is where the HB 315 LC2 crawler excavators are manufactured. The process is divided into several stages. Body parts, crawler tracks, as well as electronic components such as engines, pumps, and distributors are manufactured in different shops, and only at the very end of the production cycle meet in the assembly shop. Almost all processes at the factory are automated. Robotic machines like drilling and welding machines are responsible for complex routine work. Envelope belts and special hoists are responsible for easy transportation of parts around the facility. Armature. What makes rebar manufacturing different from many other industries is that secondary raw materials can be used as material, that is, old, used-up metal products. They are cleaned of scale, corrosion, and other impurities, and then melted to produce a liquid metal mass. This mass can already be used to form the billets we are used to seeing in the initial production stages. The billets, being red hot and soft, are passed through rolling machines. A system of special rollers processes the product in stages until they are stretched out and become similar to rebar. In the case where transverse projections are to be obtained, the individual billets are made into a kind of wire, which is then joined to the bar. Steel cables. This massive metal product is in demand for rigging, towing, lifting, and other work in the industrial field. In any case, its production begins with a special galvanized wire. The exact characteristics of the metal depend, as a rule, on where the finished steel cable will subsequently be used. The more wire used, the less flexible the cable will be. First of all, the wire is heated. This process increases the strength of the material. Then, on special equipment, the wire is twisted around a core. It can be made of metallic or non-metallic material. In the first case, the metal is pre-coated with special compositions that protect it from corrosion. In the second case, it is coated with special anti-rotting compounds. The twisting process can be repeated many times, depending on the required thickness of the rope. Lucchini RS, a global leader in steel manufacturing, has recently introduced an advanced rolling mill for railway wheels at its Lovere plant in Italy. This facility exemplifies innovation and sustainability, integrating state-of-the-art technologies for high-precision wheel production, tailored to diverse rail applications, including high-speed and heavy haul systems. The rolling mill enhances production efficiency while maintaining environmental responsibility through water recycling and reduced material waste. It forms part of Lucchini RS's broader investment strategy, aimed at modernizing infrastructure and expanding its product portfolio across international markets. Carousel tunnel segment production is an advanced manufacturing approach designed for the efficient and precise creation of precast tunnel lining segments. The system relies on a circular or semi-automated production flow, enabling continuous casting, curing, and finishing operations. Key benefits include optimized workspace utilization, reduced manual labor, and improved safety. These systems incorporate precise timing for concrete filling, vibration, and curing to meet rigorous specifications. Innovations such as automated reinforcement cage production and RFID tagging enhance quality control and traceability, ensuring compliance with project standards. Carousel systems are widely used in large-scale tunneling projects, like the London HS2 railway or infrastructure projects requiring high output and precision. Profiling. The easiest, fastest, and most affordable way to change the shape of a surface to make it more interesting is to use plasterboard panels. The only problem is that it needs to be attached to something so that it holds its shape and is securely fixed. Traditionally, all such panels sit on a frame assembled from metal profiles, but they are usually produced straight and level. In the past, to change the shape of the profile, masters made a large number of cuts on the surface and then manually bend them to give them the necessary shape. Today, you can do without unnecessary work and immediately buy these flexible profiles. Their geometry in a matter of seconds can change in almost any direction, so that the frame turns out in the end complex, with an unusual shape. When sheets of plasterboard are superimposed on top, the design looks like a real work of art, and the main master designer is practically nothing limited except their own imagination and skills. Ad hoc. Sometimes a perfect final result is 50% the skill of the contractor and another 50% the right choice of material. Just like in the case shown on the screen. Here, the builder demonstrates how to decorate a wall with a special textured paste called MS block. Its secret lies in its special composition, which includes cement, fibers, various chemical and mineral additives. Together with water, they form a unique, pliable paste, which looks extremely unusual when drying. However, the ingenuity of the master was not lacking here. As you can see, he applies the solution to the wall in an even layer, and at the same time draws patterns on the surface. And before the surface dries, he cuts strips to simulate fancy brickwork. It is noteworthy that there are countless such ways of applying and decorating, so it all depends solely on the designer and the craftsman.